What I'm going to talk about this morning is 55 new features in JDK 9. And the nice thing is I'm not going to be rushed for time. We actually have enough time to do 55 new features justice. When I put this presentation together, I originally intended it to be an hour long. And I did it at one conference, and that was good. And then some other conferences said, could you do it in 50 minutes? And I'm like, yeah, I think I probably can. So I managed to do 55 new features in 50 minutes. And then some conferences came along and said, could you do it in 45 minutes? And I'm like, just about, but it's really pushing it. So we actually have an hour and 10 minutes. So we'll be able to do 55 new features without any problem. And I've even thrown in some extra stuff at the end about what's going to happen in JDK 10 and JDK 11. So a surprise ending. Right. What I have done is I've divided this up into a number of groupings of the new features that we're going to talk about. And we'll start with the big features, the major features in JDK 9. Obviously, the biggest one is modularity, the Java Platform Module System, or Project Jigsaw. Now, I'm not going to spend too long talking about this because I could clearly spend the entire time talking about how the module system works and what you can do with it, how the different aspects are linked together, and so on. But what I do want to do is just mention a few of the key points about modularity because it is the big feature and because it will have potentially a significant impact on how you migrate applications from earlier versions of Java to JDK 9. So the first thing is that the core class libraries that we are used to, the ones that we all use to develop our applications, how those are organized has been changed. If you look back to JDK 1.0, there were about 200 classes in rt.jar. In fact, I don't even think it was called rt.jar at that point. But there were about 200 class libraries available to you to develop applications. That was good, gave you a few things to do. And I remember thinking at the time that 200 classes, yep, I can keep those all in my head. I don't need to reference the documentation too much. If you look at JDK 8, there's about 4,500 classes in rt.jar now. And I know that I certainly can't keep them all in my head, so I use the documentation a lot more than I used to. But that's a good thing, because clearly we don't have to write our own list class anymore. Now we don't have to write a SQL statement class anymore. We don't have to write an atomic class anymore. They're all there for us to use. But the idea with JDK 9 is to take this big 4,500 group of classes and break them up into more manageable chunks. Break them up in such a way that we can build runtimes for our application which only contain the modules that we need for that application. So we don't have to include everything for every application. So what we've got now is 94 modules, and of those, 36 are for Java SE. So Java SE is the standard defined through the JCP, and so the 36 modules that make that up. And then there are all these other modules which are part of the JDK itself, so some tooling, APIs, there's JavaFX, there's some Oracle-specific ones if you download the binary from Oracle. So this makes life a lot easier because now we've got different modules that we can work with. The other key thing that happened with modularity was the original decision to encapsulate the internal APIs. In addition to the 4,500 public APIs that we have available, there are lots of other methods and classes in there which are placed there to make the public APIs work. But you've never been supposed to use those in your code. So they've never been publicly documented. They've never been really talked about in great detail. The most infamous of these is Sun, Miss, Gun, Safe. Now, I really like Sun, Miss, Gun, Safe. The clue's in the name. Unsafe. You're not supposed to use it. So let's have a quick show of hands. Who has used Sun, Miss, Gun, Safe? A couple of people. OK, not many people have put their hand up. Who here uses a third-party library or a framework, like Spring? Yes. OK, lots of people do. So the chances are you have actually used Sun, Miss, Gun, Safe. You just don't know about it. Because lots of these third-party libraries and frameworks do use it. So there are some things that we need to be aware about in terms of how you can use these internal APIs. Like I said, the original decision was to encapsulate them and do away with them completely. But that was going to break a lot of backwards compatibility, so the designers decided, okay, we will allow people to gain access to them in a controlled way. There are a couple of command line options you've got. There's add exports and add opens. Add exports is if you're using something like Sunmisk Unsafe and you want to import it so you can reference it directly from your code, then you can specify which particular packages you want available and which particular parts of your application you want those available to. Add opens is effectively the same thing, but allows you to do it through reflection rather than directly accessing the classes and the methods. There's also another feature of Jigsaw, which is the idea of the modular source code. If we break up the rt.jar into all these different modules, it also makes sense to take the source code, reorganize it so it's based on the modules that are being created in the runtime. So that's a logical thing to do as well. Now, as I said, compatibility is something of an issue with this. And as I said, there's a couple of command line options that are available to selectively turn on access to internal APIs. But often people think, well, how do I go about moving an application from JDK 8 to JDK 9? What do I need to do? And the first thing you can do is essentially leave everything alone. So you just take your application, leave everything on the class path, and that will make sure that everything in the class path is part of the what's called unnamed module. And then that can interact with the module system without having to do any changes. One of the other things that the designers introduced was the wonderfully named big kill switch option. And again, the wonderfully named flag, illegal access. And there are 4 different parameters you can specify with this. The default is permit. And what that allows you to do is to use the internal APIs if you need to. And if you use one of those internal APIs, the first time you use it, you will get a warning message printed on the standard error. You can dial that up, and you can have warnings. Warnings will give you a warning every time you use an internal API. So you won't just get one message, you get it every time you use it. You can dial it up further, and you can go to debug. Debug will do the same thing, but it will give you a stack trace as well, so you can see at which point you came from in your code to use that particular API. And then the 4th option is deny, which turns off the ability to access these things, so it really turns on encapsulation. And at some point in the future, that will become the default. We don't know when. It certainly won't be in JDK 10. Maybe it'll be JDK 11. Maybe it'll be later. But at some point, the idea is to turn that on as the default. The other thing related to modularity is this idea of being able to build a runtime that only contains the modules that you need for your application. And the way you do that is using jlink. Jlink will allow you to specify certain things like the module path that you want to use and where you're going to find the modules, and it will allow you to specify which module you want to start from and build a runtime for that module. And then you can specify where you want it to be built. Jlink will then create a directory structure for you that looks exactly like the JDK. It has a bin directory, a conf directory, lib, jmods directory, and so on. And if you go into the bin directory of that runtime when it's created, and you run something like java -list modules, it will list out all of the modules that are available in that runtime. In this very simple example, what I've done is I've said just include the java.base module. Java.base has to be there. There's no discussion about that. So this doesn't really do anything. It just gives you the java.base module, and that's it. If we look at a slightly more realistic example, what I've got here is an application that I created which has got 3 modules in it and references some of the JDK modules. And I can simply say, okay, create me a runtime using jlink. Here's my module path. The module I want to start from is my app module. That contains the main method, the main entry point, and then, again, create my image. If I do list modules on that again, now I see that there's more modules. So I've got java.base, java.logging, SQL, XML, and then I've got my 3 application modules, app, zoop, and zeta. The observant amongst you will see that there are some numbers there as well. So at 9, at 1.0. And you might be thinking to yourself, oh, look, we have got versioning. No, do not get excited about that. Version numbers are there for information purposes only. And I put the quote here, which is from the State of the Module System, which is really kind of the design document for Jigsaw. And it says, it is not a goal of the module system to solve the version selection problem. So unfortunately, unlike things like OSGI, there is no ability to have different versions of a module on the module path and then resolve based on which version you need. The numbers are there just for you to look at and think, that's nice. Moving on from modularity, what other significant features do we have? Well, we've got factory methods for collections. As I said, we no longer have to have our own list class or our own set class. So there are three interfaces that define collections: list, set, and map. If we want to create a small set, for example, and we want to populate it with some values, the amount of code we have to write is more complicated than it really needs to be. And if we look at a simple example, what I'm going to do here is I'm going to create a new hash set. So I allocate a new hash set and assign it to my variable. Then, in order to add three values to it, I have to call the set method 3 times. And then, because I want that collection then to be, well, it's not strictly speaking immutable, but it's unmodifiable, I have to call the static method on the collections class and reassign my set value based on the return of that. So to get three values into my set, I've got to use 5 lines of code. What the factory methods does is it takes advantage of JDK 8's introduction of static methods in interfaces. So we can add the static methods we need at the interface level. We don't have to go down into all the concrete classes that implement list, set, and map. What the designers have done is they've added 12 overloaded methods to each of these interfaces. Now that might seem like a lot, and it is, but the idea behind this is that it gives you the ability to have a method that will add 0 elements to the collection, 1, 2, 3, all the way up to 10. And there's separate methods for each of those. If you want to go beyond 10 elements, then there's a varargs version which will take an array of values, and then you can add as many as you want. The reason for having so many overloaded methods is because the varargs way of doing things is less efficient, and so for small numbers, they decided up to 10, it was worth having separate methods for those because it would perform better. If we look at the equivalent code now, we have one line of code where we simply say, okay, our set is set.of A, B, C. Very simple, nice one-liner. Streams were introduced in JDK 8, and really one of the most popular features of that version of the platform. And so there are a few enhancements that have been made to streams in JDK 9. Two of the big ones are methods called drop while and take while. These are kind of like the skip and limit methods that we already have. Skip and limit allow us to specify a number of elements that we either want to pass before we start taking elements and passing them to the output stream. So if I say I want to skip 3 elements, I'll ignore the first 3 elements on the input stream and then pass the rest to the output stream. Limit is the opposite of that. So if I limit it to 5 elements, I take the first 5 elements and then drop the rest of them on the output stream. Drop while and take while do the same thing, but rather than using a fixed value, they use a predicate. So you have a condition, and so long as that condition is true, then you will either take elements from the input stream or you will drop elements from the input stream. Once the condition is false, it changes the way that the stream is processed. So if you say drop while something is true, you drop elements until that condition becomes false, then you start taking elements and passing them to the output stream. Take while, you take elements from the input stream until the condition is false. Once it changes, you stop taking elements, and that's the value, the limit of your input stream. The iterate method now has another overloaded version. What this allows you to do is do an iterate, which looks very much like the traditional for construct. We're all used to, for I equals 0, I less than 10, I plus plus. So there's 3 values that we pass. One is the initial condition or initial value. Second is the condition that terminates the loop, and the third is what we do each time we go round the loop. So now the iterate method has the ability to do that, so we can pass in an initial value, we can pass in a predicate, which determines when the iteration stops, and we pass in a function, which is what happens each time the iteration happens. Files.lines has been improved so that we can now use it with a parallel stream and have much better performance. If you tried to use files.lines in the past and you pass that into a parallel stream, you really wouldn't get very good performance. It would actually be worse than passing it into a sequential stream. Reason for that was that the way that files.lines worked was it was simply reading lines sequentially from the file and then passing them to the rest of the stream. The overhead of constructing the fork join pool and allocating jobs and queues and so on was more than the benefit you get from trying to do it in parallel. Now what happens is that if you pass the output of files.lines to a parallel stream, the library code will say, let's map that file into memory and then divide it up based on how many threads we have in our fork join pool and allocate each one of those areas to a separate thread. That way each thread can read independently and you actually get better performance in terms of the processing. Optional, also introduced in JDK 8, now has a couple of new methods. One of those is the ability to get a stream from an optional. And that will return either 0 or 1 element, depending on whether you have a null or a valid reference in the optional. Multi-release jar files. The idea behind this is that if you want to provide a jar file that can be used with different versions of the JVM, then you can have different sets of code that will be used for that jar file based on which JDK, which JVM you're actually using. Now, that might seem like it's not much use at the moment, because if JDK 9 is the first version of the JDK that understands multi-release jar files, then you can only put one version in there. So it's not really a lot of use at the moment. But you can actually do two, because if you use a multi-release jar file with JDK 8, it just treats it as a normal jar file. And whatever's in the top, in effect, the top level directory is what will be used. So you can create a multi-release jar file where you put JDK 8 code at the top level, and that will be used correctly by JDK 8. Then for JDK 9, you can use the multi-release construct of that and put it in like a subdirectory so that when you run it on JDK 9, the code that will be used will be the one that's appropriate for JDK 9. So you can actually use it for 8 and 9 at the moment. As we'll talk about with JDK 10 and JDK 11, obviously this will become more use in the future. JShell. This is a REPL, a read, eval, print loop. And the idea of this is something that a lot of languages have had already. And it's the idea of being able to do prototyping and understand how your code works quickly and easily. Rather than having to start up the IDE, create a new project, create a new file, go in, type in a few lines of code that you're interested in terms of seeing how they work, you can just fire up JShell, type in the commands that you want, analyze what's going on, and then see how your code is actually going to work when you develop the actual project. When I first saw this, I thought to myself, probably not going to use this a lot, but I have found it's actually very useful. So there are often situations where you think, okay, I'm not quite sure how that would work if I did, this, then that, then that. So I'll just fire up JShell, type it in, and it gives you the results very quickly. It's got all sorts of useful things in terms of it has history, it has the ability to do autocomplete, it gives you access to the documentation so that you can highlight things and then find out what they actually do. And it even allows you to leave out the semicolon at the end of the line if you don't need it. So it gives you quick and easy prototyping in that respect. Concurrency updates. Obviously, Java has always been a language that supports the idea of multiple threads and concurrency. And really, ever since JDK 5, really, we've been trying to make Java as easy as possible to use when you've got multiple threads of execution and you want them working together. One of the things that's become more popular recently is the idea of reactive threads, reactive streams. So what they've done is added this functionality to JDK 9. So there's a simple framework which really just consists of a set of interfaces. You have to implement a lot of the code yourself. But the idea is it's all about non-blocking asynchronous processing. And the way you can think of this is if you had a web server and you've got a number of clients who are trying to access that web server, the client that wants to talk to the web server can fire requests at the server, but it doesn't know how many times it can fire requests at that server before the server is going to become overloaded and it's going to block in order to do the processing. So the idea of the reactive streams is that you can set up your client as a publisher. So it publishes requests to the server. The server is set up as a subscriber. So it subscribes to messages coming from the client. So sometimes this seems like it's the wrong way around, but it actually works very well this way. So the web client publishes messages to the subscriber, which is the server. And the subscriber says, I can subscribe to a certain number of messages. So the subscription determines how many messages it will subscribe to. That way the client knows that, for example, it can send 4 messages to that server before it's going to block. When it's sent 4 messages, it can then decide, do I send another message knowing that I'm going to have to wait, or do I go to another service, in a microservices type architecture, do I shift that to another service and have it processed that way? So this is all about making life easier in that respect. So you've got the idea of publisher, subscriber, a subscription to link the two together, and also what's called a processor where you can chain together both publishers and subscribers. The other thing you can do is, as the server is processing things, it can change the subscription. So it can say, OK, I've processed a number of messages. Let's update the subscription to say that I can subscribe to a larger number of messages. And that way the client knows exactly how many messages it can send at any time. The other part of concurrency updates is the completable future, or some changes to the completable future. Completable future was introduced in JDK 8. And again, it's the idea of looking at how to do things in a more asynchronous way. Way back in JDK 5, we got the idea of a future. And a future is used with a callable. So we set up a callable as a new thread of execution, and that's going to generate some sort of result. In order to get that result, we have our future, and the future has the get method. So we call the get method when we want the result, and that get method will either return the result if it's ready, or it will block until the result is ready. So that's blocking. We don't like that. We want it to run asynchronously. Completable future, rather than using the future and a get method, you register a callback method. So when the result is ready, the callback method gets called, and the processing can continue out that way. So completable future has proved to be quite useful, quite popular, and a few things have been added to that. So there's things like delays and timeouts to make it easier to do that sort of thing. People often subclass this, so there's better support for subclassing. And there are a number of new static utility methods. And what this is all about is when you could actually create a sequence of methods that are used in terms of callbacks. And these are referred to in terms of the completion stage. Now, I'm going to read you the Java documentation for minimal completion stage, because it is worth listening to this. So minimal completion stage returns a new completion stage that is completed normally with the same value as the completable future when it completes normally and cannot be independently completed or otherwise used in ways not defined by the methods of interface completion stage. If this completable future completes exceptionally, then the returned completion stage completes exceptionally with a completion exception, with this exception as cause. All the words are English, but I have no idea what it means. At some point, somebody's going to explain to me what a minimal completion stage really is and what it does. There's also the idea of a failed stage, and then there's a couple of methods that I particularly like, which is a new incomplete future and a failed future. Deprecation has been enhanced. Now, we've had deprecation right from JDK 1.1. And deprecation has proved to be a sort of bit of a double-edged sword, really. Lots of things have been deprecated over time. But up until JDK 9, nothing has ever actually been removed. And this is one of the big changes in JDK 9, is some things have been removed. But we've also enhanced the way that the deprecation works. So we had the deprecated Java doc tag. We had the deprecated annotation introduced in JDK 5. So now there's 2 new methods in the deprecated annotation. The first of those is for removal. That will return a Boolean. If that returns true, then the intention of the Java developers is for that particular element to be removed in the next release of the JDK. So it gives you fair warning that the next release, that thing is going to disappear. If it returns false, it means that it may be removed at some point in the future, but you know it won't be in the next release. So it might be some point in the future, but maybe not. And then the other thing that you've got is a method called since. That will return a string, which is the version where this particular element was deprecated. Now, what they haven't done is gone back and retrofit that, so you won't get information about all the things that have been deprecated in the past. But from JDK 9 onwards, you will get information about that. Several new elements have had the deprecated tag added to them, which is quite logical. But interestingly, 2 have had the deprecated tag removed. So if you look at java.awt component show and hide, they no longer deprecated. Which begs the question, how do you describe that? Because if they were deprecated, now they're de-deprecated or they're precated. I'll leave you to decide. There's also a useful tool called jdeprescan, and that will produce a report of a class or a jar file telling you what things you've used in there which are now deprecated and give you more information about that. Changes to the language itself. Project Coin was one of the things that was introduced in JDK 7. It was a set of small changes to the language itself. Things like strings in switch statement, things like the try with resources, and so on. So there are a few new changes in JDK 9. First of these is that a single underscore is no longer valid as an identifier. It's now a reserved word. So hands up, anybody who's used a single underscore as a variable name. I don't see anybody. Okay, very good. Well, if you were really dedicated to this, I checked, and you can still use 2 or more underscores as a variable name. But the reason for this is that it's probably not JDK 10, it's probably JDK 11. A single underscore will be usable in a lambda expression. And the idea is that if you have a parameter in your lambda expression which is not used in the body of the lambda expression, you can use a single underscore to, in effect, sort of make it invisible or hide it to some extent. Private methods in interfaces. As I said, JDK 8 introduced the idea of having static methods in interfaces. Also introduced default methods in interfaces. So now we have behavior in an interface as well as types. The idea here is to extend that a little bit so that you can have private methods in an interface, so that if you have common code between a number of static methods or default methods, you can move that into a private method and then have that shared by the other static or default methods. Effectively final variables in try with resources. Try with resources is very useful, and one of the drawbacks is that if you have a reference to something, a resource, that you have defined outside of the try resource block, you still have to assign it to a new variable in the top of that try block. Now, with the change to the syntax, you can use the reference without having to assign it to a new variable name. Just tidies up a little bit of code there. Safe varargs with private instance methods. Safe varargs is an annotation which allows you to tell the compiler, okay, there's certain situations where the compiler will issue a warning message based on the use of variable arguments and generic types where things can get a little bit confusing. So it will issue a warning message even though there's nothing you can do about it. So you can turn that off. And currently you can use that with constructors, you can use it with final methods and static methods. Adding private instance methods just tidies up the syntax there so it applies to all correct types of methods. And the last one in terms of Project Coin is extending the way that the diamond operator works. So diamond operator is about using the compiler to do type inference. If you've got list of type string and you want a new array list, you don't actually have to specify that it's an array list of type string because the compiler will work that out for you. So you just put the brackets there, or the less than, greater than. One of the drawbacks is that with the diamond operator, you can't use that in JDK 8 with an anonymous class. The reason for that is that there are situations where the compiler can generate a type or infer a type that is non-denotable. That means that the compiler understands what the type is, but it's not one that can be represented in the class file structure and understood by the JVM. So now in JDK 9, if the type that's inferred by the compiler is denotable, so it's one that's understandable by the JVM, then you can use the diamond operator. really, the advice that I would give there is just use a diamond operator and let the compiler decide whether or not it will work or not. Standards. Lots of standards get used in Java, so many of these need to be updated. Unicode is one of the ones that is used by Java, and so I looked at this, and it turns out there are 2 updates to Unicode since JDK 8 was launched. There's Unicode 7 that introduces 2,834 new characters, and there's Unicode 8 that introduces 7,716 new characters. So 10,000 new characters. And I thought to myself, where did they find 10,000 new characters to add to Unicode? The answer is emojis. So, obviously. But also, interestingly, lowercase Cherokee is included. There was uppercase Cherokee, so you could shout in Cherokee, but now you can have lowercase Cherokee. Other things that have been updated. So things like the key store is now going to be public key cryptography standard 12 rather than the Java key standard, or Java key store, sorry. JavaDocs now uses HTML5, so we have some slightly nicer looking JavaDocs, and the algorithms used by SHA-3 have been updated, essentially to keep us ahead of the hackers. A few smaller features in terms of standards. Property files now have the ability to use UTF-8 encoding. So you think to yourself, wow, what does that mean? Well, it means you can use Unicode, which means that your property files can now have emojis or lowercase Cherokee. Secure random implementation has been switched to being used or using DRBG. I looked this up, and DRBG is deterministic random bit generator. This doesn't make any sense to me, because to me, random is non-deterministic, not deterministic. But anyway. And then the XML catalog API has been updated to version 1.1 of the OASIS standard. This is used by JAX-P, and so that's now part of what's being used. Looking into the JVM, what has changed? Okay, so the first thing is that the default collector for a server class machine is now G1. Server class machine is one that has 2 or more cores, 2 or more gigabytes of memory, and is not running Windows. I didn't make that up. That's what Oracle have defined. So they've decided that rather than using the parallel collector, which is what the default used to be, G1, which is now mature collector, it's been around for about 10, 12 years now, actually, has been decided that they will use that instead. It's really designed as a low-pause collector, works concurrently with various things. There have been some updates around JDK 8 to improve things, but it's the idea of using a low-pause collector rather than a high-throughput collector. One of the things I will say, because I do work for Azul, so this is a brief marketing message, is that G1 does still fall back to a full compacting collection, which means you can get very long pauses for your garbage collection. Pauses will be proportional to the size of your heap, not to the amount of data. If that is a problem for you, please do have a look at Zing, because that is truly pauseless garbage collection. End of marketing message. Better string performance. Several things happened here. So the first is that if you look at the way that the JVM represents strings internally, it has always used 16-bit encoding. And for most applications, certainly if you're in the US, Canada, Western Europe, you don't need 16-bit encoding. Most people use 8-bit encoding. They use like ASCII, ISO 8859-1, 2, and so on. So now the JVM will do that. The way that works is that there's a flag at the beginning of the string that says, is it an 8-bit encoding or is it a 16-bit encoding? If it's using ISO 88591, it sets the flag to say, yes, it's 8-bit encoding, and it effectively halves the size of the string that's used by the JVM. The other thing to help with the amount of space that's used for strings is that strings can now be stored in the class data sharing archive. And that means that if you've got a number of JVMs all running, let's say, the same application, and they all have the same set of strings that they're processing, then you can put them all in the class data sharing archive, which is shared amongst those JVMs. One copy of the strings rather than multiple copies of the strings, reducing the load on the memory of your system. Last thing that's been done to improve string performance is that string concatenation has been changed in terms of the compiled bytecodes. Now, string concatenation uses invoke dynamic, And that effectively changes how the implementation works. Rather than hard coding the implementation of string concatenation into the bytecodes, it allows the JVM to decide at runtime how best to do that. And that means that as new ways are found of concatenating a string, if it's possible to find new ways of concatenating a string, then those can be used to improve performance. So that's a small change that's been made to do that. Graphics rendering. What's happened here is that if you look at OpenJDK, there was an open source graphics renderer called Pisces. That didn't have very good performance, so that's the sort of green squiggly line at the top there. That's latency, which means high is bad. What Oracle did was they replaced that with a closed source implementation called Ductus, which had better performance. Now, to eliminate the need for a closed source implementation, there's a new open source implementation called Marlin that has pretty much the same performance as the closed source one. So it's just open source, better performance. A few smaller features, improved contented locking. This is a very low level JVM feature. You won't see any difference in terms of coding or anything like that. It just sorts out some of the ways that things like field reordering and cache line alignment work internally in the JVM. Similarly, for encryption, the idea is to take advantage of CPUs that have the ability to do encryption on the silicon rather than having to do it in software. And so now CPU instructions can be used by the JVM directly and have much better performance. If you look at the different benchmarks that have been run to test this, it's anything up to 150 times better than using the software implementation. For anybody who's using JavaFX, there's a new version of GStreamer that's used through the media class. Again, nothing changed in terms of your code. It will just be picked up automatically. A few smaller features. Segmented code cache. This is related to the JIT compiler. And what this is a sort of a basic set of groundwork that needs to be done to improve some of the way that JIT compilation and JIT performance works. So now there's three different areas that are used for JIT code: non-method, profiled, and non-profiled code. And what this is about is allowing the designers to work on things that they can do in the future to optimize code in different ways based on where the code is in the cache. Unified JVM logging. This is actually something that is quite significant because, again, of sort of backwards compatibility and so on. There's now a common logging framework that's used for all the different messages that come from the JVM. And one of the things that people frequently use is GC logging. So now the GC logging is using the unified logging framework, which means, A, that you need potentially to use different command line options to set up what you want to come out of the logging. And the second thing, or B, is that you may have to change, if you're parsing log files, you may have to change your parsing code based on some changes to how the logging messages are actually output. Specialized features. So I couldn't find an appropriate icon here, so I just put a minion. Spin weight hints. This is, for Azul, this is great because this was a JEP that we proposed for inclusion in the JDK. And it's the first JEP that's been submitted from outside of Oracle and included in the JDK that's been released. So what this does is it adds one method to the thread class on spin weight. What that does is it says, if you know enough about your code and you know that there's a chance that you'll be spinning the processor waiting for a lock to be freed by another thread, if the processor supports the pause instruction in the x86 instruction set, then the JVM can use that. And this can actually reduce the power consumption of your processor. It can improve the performance of certain situations. So things like the disruptor, we found we actually get better performance with. So it's a small change, but it's quite significant in some ways. Variable handles. Now, I said that Sun-Misc Unsafe is going to be encapsulated at some point. People want some of the functionality that's available in Sun-Misc Unsafe, and variable handles is about giving you a public API for some of that functionality. What it does is allow you to provide two types of instructions. One is for fencing, and fencing is where you have a particular section of code, and again, you need to know quite a lot of detail about what your code is doing, because the JVM, if you look at the specification, is allowed in certain situations to reorder instructions to improve efficiency. But there may be particular places where you don't want the JVM to do that. So if you fence those operations, you can prevent it from reordering loads or reordering saves. And so you can use the acquire fence and release fence to do that. Similarly, you can have the ability to do atomic operations on primitive values. You can do atomic operations with Java at the moment, but you need to use the atomic class, and therefore you need to create an instance of a class, put the primitive value into that class, do the atomic operation, and then there's the overhead of garbage collection. To avoid that, you can do an atomic operation on a primitive value through a variable handle, and you can do things like compare and exchange, compare and set, get and add, and so on. Ahead of time compilation. This is an experimental feature that was introduced in JDK 9. And the idea behind this is to help to eliminate or reduce the warm-up time that's associated with JIT compilation. When you run Java, you load the bytecodes and it starts in interpreted mode. As those bytecodes are interpreted, the compiler or the JIT compiler and the JVM will decide which methods are being used frequently and will then compile them using C1. It will then profile more, and it will then recompile them using C2 to give more optimal code. What ahead-of-time compilation does is it says, OK, let's take the bytecodes and compile them into native instructions ahead of time, a bit like C or C++. That's great, because then you can run those as your application, and you get immediately much better performance, because you're not doing interpreted mode. But the problem is that JIT compilation knows more about what the code is doing at runtime than you can know ahead of time. So the idea is that what you do is you start with ahead of time compiled code, you run that, you still profile it, and then as things are identified, it can then be recompiled by the JIT to give you better optimized code and give you faster application code. So there's various ways of using this. At the moment, the only module that has been AOT compiled is the java.base. But you can AOT compile your code as well if you want. But like I say, it's an experimental feature. It's likely to have more impact in later versions of the JDK. Smaller features. There is better control over the compiler. That's not Java-C, that's the JIT compiler. So you have a directive file that you can use to say, OK, I know this method is one that I'm going to use a lot. So compile that method as quickly as possible, rather than waiting for it to be identified by the JVM as a hot method and therefore compiled. So it's allowing you to give some information to the JVM, to the JIT compiler, to allow it to do things ahead of time, or not ahead of time, but as quickly as possible. There's also changes to the process API. There's a new class called process handle. What that does is give you more information about native processes on the machine that your JVM is running on. You get information like the process ID, the arguments that were passed to a particular command, when it started, how much CPU it's utilized, and the name of the executable. You also have better control over the executables on the machine, so you can actually say, OK, I want to terminate this process. As long as you have the correct permissions, then you can do that through this API. Housekeeping. A few things that have been tidied up. Right, new version string format. This is good. Right, so version strings in Java are quite entertaining. And I wrote a blog about this because it turns out that there's been almost as many version string formats as there have been versions of Java. Because when we started off with Java, we had Java 1.0. OK, very logical. Then we got Java 1.1, which really should have been Java 2. But OK, it was 1.1. Then you got 1.2, but it was actually Java SE2 version 1.2. Then you got 1.3, 1.4, 1.4.1, 1.4.2, and then we got Java 5. So we missed out a whole bunch of numbers, and then we got Java 5. Then it was Java 6, then it was Java 7, then it was Java 8. But interestingly, if you go to Java 8, you download Java 8, JDK 8, and you do Java minus version, you actually get JDK 1.8.0 underscore whatever the update was. So this all got very confusing. Marketing got involved, engineering didn't agree, and various things like that. So the idea was let's have a new version scheme for Java. Let's make it more logical. So we'll have 4 numbers: major, minor, security, and patch. Easy to understand by humans, easy to understand by computers, more of a semantic versioning way of doing things. So that was all very good. So that went along. JDK 9 is now JDK 9, JDK 9.1, and so on. Very nice. Except we decided that's not going to work. So we need a new version string format. So the new version string format was going to be year and month. So this was the idea of doing like Ubuntu has been doing. So you'd have JDK 18.3, which was going to be the next one, 2018 in March. Then the next one was going to be 2018 in September, so 18.9. Okay, that wasn't very popular. A lot of people didn't like this idea. So that one went away as well. So now we have another new, and this is kind of hot off the press, in fact, because this was only this week that this one came out, because there was another one between the two that I've just explained. So now we have feature, interim, update, and patch, which looks very much like the one that we had for JDK 9, except it's got an extra number at the end. So feature was going to be major, so this is 10, 11, and so on. Minor, why they say this, I don't know. Minor is always going to be 0. Well, if it's always going to be 0, why is it going to be there? Why do I need that number? Then we've got, because it's future-proofing it, I suppose. Then we've got update, which was going to be security, so that's when they have to release an update to the release. And then patch is if they have to do an emergency patch between scheduled releases, then you'll update that number as well. The file structure of the JDK is changing. So in the old days, we had the JDK directory, then we had a JRE subdirectory. JDK directory had a bin directory, which had Java in it. It had a lib directory, which had tools.jar in it. JRE had a bin directory that had Java in it. So you had 2 versions, or 2 copies of Java, 2 for the price of 1. And you had rt.jar in the lib directory. JDK 9, that's flattened out. So now we have 1 bin directory, we have 1 conf directory, lib, jmods, and so on. The idea of this is that, like I said, with jlink, you build the runtime for your application, only contains the modules that you need. The important thing is no more JRE subdirectory, no more tools.jar, no more rt.jar. Smaller features. Okay, so my favorite feature of JDK 9 is the fact that we finally have searchable API documentation. Now, I know some people have pointed out to me that, yes, browsers do have a search facility, so you can do searching, from a browser. But it is actually nicer to have a little search box because it gives you more information. If you start searching on something, it'll tell you what classes are available that match that, what methods are available that match that, and so on. So I really do like that feature, and I can't believe it's taken 22 years to get to the point where we have a search feature on the documentation. The annotation pipeline has been updated. There's support for repeating annotations, Lambda type stuff as well, various things like that, and a new annotation pipeline. Parser API for Nashorn has been updated. There's also support for not quite the most up-to-date spec, but ECMAScript 5.1 is now supported by Nashorn, which is the JavaScript engine for Java. General cleanup. Disable SHA1 certificates, so the idea is that those shouldn't be accepted anymore, almost completely, but there are some situations where SHA1 certificates still need to be accepted, so they have left those behind. The applet API has been deprecated, so anybody still using applets? No, I don't see anybody. Okay, well that's good to see because Tumbling Duke has gone. No more tumbling. Things that are removed from JDK 9. I did say that there's some changes in this respect so that we don't have, or we've made a change in the sense of not just adding things to the JDK. Now some things are actually being removed. So 6 methods have been removed from the standard class libraries. Add and remove action listener in the pack200, unpack200, and log manager classes. So you look at that and you think to yourself, what did those methods do that was so bad that meant those 6 got removed? And the answer is that when they had to divide up all the class libraries into these 97 or whatever it was, different modules, there were some links between things that caused a lot of problems. And these 6 methods were the ones that they said, okay, if we remove those 6 methods, it makes our life a lot simpler in terms of separating out the modules. There's also a class that has been removed, so the dialog callback handler as part of the Java authentication and authorization service. You cannot select a runtime version based on -version:"release" anymore. So you can't run older versions of the JVM in effect through the JRE. -version does still work, so you can get the version number of whatever you're using. Demos and samples, they kind of got very dusty, very old. Nobody was updating them, so they have all been removed in JDK 9. Other things that have been removed from JDK 9, a couple of management type things. So the tools interface, hprof agent has gone. That was only ever intended as a demo. Things like JMap, now a much better way of doing that. The JHat tool, which was an experimental thing added in JDK 6, never been supported, that's gone as well. Various garbage collection options have been deleted. So these were all deprecated in JDK 8. If you've been using them, you will get a warning message already, so you should know by now that they are going to go. Things like parallel new and serial old, which is a very strange combination that doesn't work anymore, and mostly around incremental concurrent mark sweep. So those combinations are now no longer accepted. What next? So that's 55 new features in JDK 9. What is happening next with Java? So a few things that have happened in the last probably 3 or 4 months that are quite significant in terms of the future of Java. So the first is there is a new release model. The idea is that there will be a new version of Java every 6 months. So that means we're going to have 2 versions of Java every year. First of those is going to be in March of next year, which is actually 7 months since the last version, but we'll forgive them for that. So March next year, we're going to have JDK 10. That was what it was going to be called 18.3, but now it's going to be called JDK 10. And then in September, we'll have JDK 11. Following March, we'll have JDK 12, and so on. Great. The idea behind this is to make development of OpenJDK more agile. People want access to the features more quickly. The goal has been in the past to have a new release every 2 years. It was 3.5 years between JDK 8 and JDK 9. So they clearly weren't being able to hit that target. What this does is say, OK, rather than taking a feature and saying, right, we will build this feature and we will target it at a specific release. So Jigsaw was targeted at, well, JRE 7, then JRE 8, now JRE 9. But rather than doing that, it's like saying, OK, when we get to March, we will release whatever is ready. When we get to September, we will release whatever is ready. So the list of features is going to be quite small, but it's only things that are ready to release rather than things that you think are going to be ready to release. JDK Updates. This is also changing, and this is quite significant because this is more about how you deploy your applications. So Oracle has said that because they're now moving to a 6-month release cycle for the JDK, they're not going to be doing what they've done in the past. So if you look at the way things have worked in the past, when JDK 8 came out, obviously there was support for JDK 7. They continued issuing public updates for JDK 7 for about 18 months, nearly 2 years after JDK 8 came out. Gave you time to get used to JDK 8, make the gradual move. JDK 8 has updates currently, even though JDK 9 has been released. And that will continue for some time in the future. That's going to change moving forward, because with 6-monthly releases, they can't have continuous overlap of all these different releases. So there will be what's called a long-term support release. Long-term support release will have 3 years of public updates. And there will be one of those every 3 years. But all the ones in between are going to be called feature releases. So right now, JDK 8 has been termed a long-term support release. JDK 9 is a feature release. It is not a long-term support, which means it only has public updates until JDK 10 comes out in March of next year. JDK 10 is a feature release. It will only have public updates for 6 months until JDK 11 comes out. JDK 11 is a long-term support release, and so it will have 3 years of public updates from September of next year. One of the big changes is there will be no more overlap. So when JDK 11 comes out, the next long-term support release, that's it for JDK 8. No more public updates after September of next year. And so if you're using Java and you're not paying for a support contract from anybody, then you need to think very carefully about how you're going to do things moving forward, because there won't be public updates for JDK 8 after September next year. What's JDK 10 going to have in it? Well, right now there is a JSR for JDK 10 that was submitted. Expert group has been formed with the usual suspects. So there's Oracle, IBM, Red Hat, SAP, and Azul. Me, in fact. And I have a JSR call tomorrow morning at 6 a.m. to look forward to talk about what's going in JDK 10. So there's a schedule approved for that. So feature complete is, next week, I think. And then release candidate will be in February, general availability in March as proposed. Early draft review is already out there, so you can have a look at what's going in there. In terms of what will be in JDK 10, there's a few things that have been proposed. So there's a new interface for the garbage collector internally in the JVM. So this is not programmatic from Java into the JVM. It won't allow you to control the garbage collector from your code. It's about enabling a new garbage collector to be added in a much simpler way. So you can just use the interface in the JVM and put a new garbage collector in there. G1 is going to be made fully parallel in terms of some of the collection cycles that are used. That still won't eliminate all of the pauses. So again, if you're interested in truly pauseless garbage collection, talk to me later. Application class data sharing. This is using the class data sharing archive. We have the JDK classes in there. We have strings in there. Now it's the idea of putting application class data in there as well. So you can share that amongst JVMs. And heap allocation on alternative devices. What this does is allow the heap to be split across volatile RAM and non-volatile RAM. So there's different ways of doing that. The big thing in JDK 10 is the idea of local variable type inference. This is the introduction of var into Java. So it will look like some other languages. So now we'll have the idea of saying, OK, var list equals new array list of type string. The compiler can obviously infer that list is going to be of type array list or array list of type string. If we do var stream from list.stream, then the compiler will infer that that's a stream of string because it knows where the stream is coming from. There will be no val. So it's not like other languages where you have var as a variable and val as a fixed value. The decision has been made that we have final already, so we don't really need val. So that's the decision. JDK 11. There is a JSR that's been submitted for this. The expert group is being formed at the moment. It's very likely going to be the same people who are already on the JDK 9 and JDK 10 expert group. The idea is to use the JSR and have it more of a rolling JSR, so you don't have to create a new one every time. Ideally, what we'd like to do is just update it each time we have a new version of the JDK. At the moment, there's not really much detail about that. There's a couple of JEPs that have been proposed for this. One is 318, which is the epsilon garbage collector. This is quite entertaining because the epsilon garbage collector is no garbage collector. So what you do is you run your application and it never collects garbage, so you'll never get pauses. But you do need to be very careful because as you allocate objects, if you don't do garbage collection, you will run out of memory. So really this is designed for testing. It's designed for testing different garbage collection algorithms and being able to isolate the code so you can run your application without the garbage collector, see how well it performs, then put the garbage collector in and find out what the overhead of the garbage collector really is. But there are people who have suggested that there are certain situations where you have very precise code where you know exactly how many objects you're going to allocate and they're only going to be run on those objects and you will never create any more intermediate objects, so you'll never do any string manipulation. And so you can use this collector potentially with that. Dynamic class file constants, I looked at this as a very low-level JVM type thing. So again, from a developer perspective, it doesn't really make any difference. To summarize then, so one thing I will mention is Zulu Java. This is, again, what we do at Azul is we take OpenJDK and we build it into a binary. So you have an alternative source of your JDK binaries. We build it from OpenJDK, so it's purely open source. We pass all of the TCK tests on that, so we make sure that it is truly conforming to Java. We produce binaries for Windows, for Linux, Mac, and it is free, completely free, no problem at all. Obviously, if you want support, then we will happily talk to you about that. We support older versions, so we have JDK 6, 7, 8, and 9, and we will continue to do that moving forward. So if you're interested in that, you can go and have a look at that at zulu.org. So just to kind of summarize then, JDK 9, big new feature is modularity. Lots of areas that are affected by this. jlink is interesting from the point of view of building runtimes and so on. Smaller developer features, new APIs for streams, the reactive API, the JShell, and so on, and lots of smaller things that I've been through during the presentation. What I would say is, if you're not already testing your code with JDK 9, you need to do that because, as I say, with the change in terms of the long-term support policy that's being implemented, you probably won't be deploying to JDK 9 because it's not an LTS release, but you need to think what you're going to do after September of next year. Are you going to be moving to JDK 11, or how are you going to deal with things if you can't get public updates for JDK 8? And that is it, so thank you very much.